Section 3.1, Defining the Derivative. This is all from OpenStax Calculus Volume 1. At the bottom of every page there's a link to go, and you can download the textbook in its entirety. It's a great textbook, and these videos are meant to supplement and help you go through that textbook. So I would totally suggest that you look at both. So let's go ahead and look at what the derivative is. Let's unpack this. Consider the function that passes through the points 1, 5, and 5, 13. To find the slope, or the rate of change, we would calculate m equals y2 minus y1 divided by x2 minus x1, and we would get 2. So the slope between those 2 points is 2. So let's follow through that same process. What if we had an arbitrary set of points? What if we had the point a, f of a, and x, f of x? Well, that slope, and this is actually going to be, we're going to call this the slope of the secant line. That would be f of x minus f of a divided by x minus a. Okay, well, what if we only considered, we're going to look at these two graphs here, what if we only considered the change from the point A? If we did that, then we would have a separate formula, and this is really thinking of change in y over change in x. And we can use these interchangeably. We could think of this as f of a plus h, where h is a small change, minus f of a over h. So the substitution here is x equals a plus h. Okay, so if you did a plus h minus a, you get the h in the denominator, and you would get the f of a plus h. Okay, but that is the substitution we're really making there. Now these two equations, as I said, can be used interchangeably. And there are good times to use each one, but this is called the difference quotient. The second one there is called the difference quotient. F of a plus h minus f of a over h. All right, so there's the graphs that we want to get that idea from. And then let's continue on. So as the change in x approaches 0, we see a more accurate slope. Okay, so if we took a secant line, I'm just going to draw it on here. If I took the secant line between these 2 points here, well, what if I take a point that is closer to A? All right, well, that would be, drew that on the wrong graph. If I put a point right here, well, the slope of that secant line is a little bit closer to what's happening on the graph itself. Okay, so as the change in x, as I get closer and closer to A, we have something we're going to call the instantaneous slope. And the formal definition will be forthcoming. All right? So let's first go ahead and look at the slope of the secant line for the function f of x equals the square root of x with the given point 4, 2 and the value of x. All right, so that means we are going to have the point a, f of a, that is the 4, 2. All right, and our value of x is 5. So this is going to be, so for the slope of the secant line, okay, f of x minus f of a over x minus a. Well, our value of x is 5, so we'll plug in 5. That is going to be the point 5 square root of 5. So this is the square root of 5 minus 2 over our x value, 5 minus our point of 4. And that is approximately 0.2360679. Okay, if we're just rounding out to a bunch of decimal places. Okay, that's what the slope is. Okay, well, let's next consider the value x equals 4.5. So the idea is that we're getting close or closer to 4. I'm going to leave that as the square root of 4.5. All right, so that slope of the secant line is f of x. That'll be the square root of 4.5 minus our y value that we were given is 2. Okay, 4.5 minus 4. If you notice, the denominator is approaching 0. Those two numbers are getting closer together. Well, that is approximately 0.2426406 if we calculate that. All right. It's all well and good. We had 0.38, was it? 0.236, and we have 0.242. Well, let's calculate that once more, but we'll use the point 4.1 square root of 4.1. All right, well, the slope of the secant line will be the square root of 4.1 minus 2 over 4.1 minus 4. Again, the denominator is approaching 0. Those are getting closer together. And that is approximately 0.2484567. Now, I want to make this note. All right, note that as the limit as x approaches 4, f of x, or our slope of our secant line, okay, is approaching 1/4. And here in a couple of problems, we'll see why that is happening. But as we get closer to 4, the slope of our secant lines is approaching 1/4. That is going to be our instantaneous rate of change once we get there. All right, so here's a definition. Let f of x be a function defined in an open interval containing a. The tangent line to f of x at a is the line passing through the point a f of a, having a slope of m equals the limit as x approaches a of f of x minus f of a divided by x minus a, provided this limit exists. Now, equivalently, we can use the difference quotient version of this, but this will be the limit as h approaches 0. Now, we will use both of these, and in the end, you can pretty much pick which one you want. All right, so let's go ahead and dive into this. We're going to use the first equation on this one. Find the equation of the line tangent to the graph, f of x equals x squared at x equals 3. Okay, so let's go ahead and use that first one. So first, let's find our slope. All right, the limit as x approaches a, in this case that is as x approaches 3, of f of x. Well, f of x is x squared. Okay, and we have f of a, that is going to be 9 because this is the point 39. Okay, divided by x minus a, so x minus 3. All right, well, based on our last chapter, this is going to be the limit as x approaches 3 of x plus 3. That factors and cancels, and so that limit is 6. So our slope is 6. All right, now let's take our point and we'll say y minus y1, or y minus f of a if you're looking at this formula right here. F of a, so y minus 9 equals slope times x minus 3. Y minus 9 is 6x minus 18, and adding 9 to both sides, 6x minus 9. Okay. Take a minute and soak that in, okay? Go back at the point of a video is that you can pause and rewind, okay? So take a minute and soak that in. See why that makes sense, okay? So I'm going to go ahead and do the same problem using the second equation. So my slope is the limit as h goes to 0, of f of x plus h, or a plus h. I'm going to go ahead and write the equation in here, f of minus f of a over h. So if I plug in a plus h, okay, a plus h squared is a squared plus 2ah plus h squared. So evaluating that, I'm going to have the limit as h goes to 0 of a squared. Well, in this case, a is actually 3. This is the point 39. So if I plug in 3 there, that is 9 plus 6h plus h squared minus f of a, which that is 9 over h. Okay, well, a couple of things cancel first off. The 9's cancel, and then we can divide an h into everything. So this is the limit as h goes to 0 of 6 plus h. As h goes to 0, that limit is 6. So our slope is 6, just as we had before. So this is y minus 9 equals 6 times x minus 3. And doing all the same distributing and algebra there, we get y equals 6x minus 9. All right, for our next question, find the equations of the line tangent to the graph f of x equals 1 over x at x equals 2. Okay, so let's go ahead and make a point. That is 2 comma 1/2. Okay. Now, it does not matter which of these two we use. I'm going to go ahead and use the second equation. Okay. Now, I'll go ahead and use the first equation. So slope is f of x minus f of a. Okay, so f of x is 1 over x. F of a is 1/2 divided by x minus a. Okay, now I need to make a note here. The limit as x approaches 2. Okay, well, this is a complex fraction, so we'll go ahead and clear that by multiplying by 2x. All right, so that'll be 2 minus x over 2x times x minus 2. Okay, well, the x minus 2 and the 2 minus x cancel, which gives us negative 1 over x, or over 2x. And so my slope as x approaches 2 is negative 1/4. Okay, now let's go to our point slope. Y minus 1/2 equals m, negative 1/4, times x minus 2. Distributing our negative 1/4, negative 1/4 x, plus 1/2, adding 1/2 to both sides, negative 1/4 x plus 1. All right. Now, to continue to show that these are interchangeable, I'm going to go ahead and use the second equation for this next one. So I have find the equation of the line tangent to the graph f of x equals square root of x at x equals 4. All right, so my point is 4, 2. And I would like to point out this is going to be very similar in answer, at least, to that first question that we did. All right, so that is our slope will be the limit as h approaches 0 of f of a plus h. So this would be the square root of a plus h. Oh, and our value of a is actually 4. So 4 plus h minus our y value there. So minus 2, because we're evaluating at a there, over h. All right, we'll multiply by our conjugate would be a good choice here. Do that in blue. Square root of 4 plus h plus 2. Square root of 4 plus h plus 2. All right, carrying on our limit, we cannot forget that. That's really important. We get 4 plus h minus 4 over h times square root of 4 plus h plus 2. Okay, a few things cancel out here. One, the 4's and the h. So this becomes 1 over the limit as h approaches 0, 1 over the square root of 4 plus h plus 2. Now, we actually pulled this conjugate trick previously in Chapter 2. So as h goes to 0, this approaches 1/4. Right, so the slope is 1/4. All right, now we have y minus y 1 equals 1/4 x minus 4. Y minus 2 is 1/4 x minus 1 minus 1. And y equals 1/4 x plus 1. And there is the equation of our line that is tangent to that point. Okay, now notice that the slope here was 1/4. This is why I made a reference back to that other one. We noticed that our slope was approaching, it was 0.248 something. And I said that notice that as x is approaching 4, that the slope of the secant line is approaching 1/4. That's exactly what just happened right there. All right. So what we've been doing is finding the derivative. Okay, so here is the definition of that. The slope of the tangent line at a given point is called the derivative. And the process of finding our slope, that limiting process, limits are the most important thing in all of calculus. This limiting process, the finding we did, is called differentiation. All right, so we now make this definition that f prime of a, that is our derivative of f of x at a, is equal to that limit that we have just found. And both of these are equivalent as necessary. All right, so let's go ahead and use this. All right, so for x equals x squared, use a table to estimate f prime of 3. Now, I'm not a big fan of this method because using the limits is a lot more accurate. However, we'll go ahead and do this. So f prime of, let's see, how do we want to say this? We'll go ahead and say the slope of our secant line is f of x minus f of a, which in this case would be 9 over x minus 3. So that is the function that we're looking at. Now, we want to know what this approach is, so we're really looking at a limit. Okay, so f prime of 3 is the limit as h goes to 0, or as x approaches 3, of x squared minus 9 over x minus 3. It's that limit. Okay, so if we look at a table, I'm going to actually make a table of the function x squared minus 9 over x. So x squared minus 9 over x minus 3. All right. So as you approach 3 is the idea. Okay, ask. All right, so as I approach 3, so say at a value of 2.9. Okay, this is x squared minus 9 over x minus 3. At a value of 2.9, it is 5.9. At a value of 2.99, we have 5.99. Okay, so it appears that it might be getting close to 6. Okay, let's go the other direction. Let's go 3.1. 3.1, the value is 6.1 of that slope of the secant line. 3.01, the slope is 6.01. So it appears from this table that is approaching 6. Now, if we evaluate the limit itself, that is the limit as x approaches 3 of x plus 3 because it cancels. And our limit is 6. So we can estimate f prime of 3 to say it, based on a table, let's say it is approximately 6. But we can say from our limit definition, f prime of 3 is equal to 6 based on that limit. All right, number 7, find the derivative of f of x equals 3x squared minus 4x plus 1. And we want to find f prime of 2 specifically. All right, so we'll use our first equation here. So that would be the slope. Okay, the slope, and we're using a is 2. So really we have a point 2 comma 12 minus 8, that's 4, that's 5. Okay. All right. Yeah. Okay. So f of, so this will be the limit as x approaches 2 of f of x. What is that definition? F of x minus a. So f of x, so we'll go ahead and just plug that in there. 3x squared minus 4x plus 1 minus f of a, which I just said is 5. And I'm just going to go ahead and check that real quick. Let's see, 3 times 2 squared minus 4 times 2 plus 1. All right, 2, 5. All right, so minus f of 2, which is 5. Okay, over x minus 2. F of x minus f of a divided by x minus a. All right, Well, if we work on that, let's see. That's going to be a minus 4. That's going to be an f of, okay, 3x squared minus 4x minus 4 divided by x minus 2. And I'm going to go ahead and take a stab at factoring that. That'd be 12. So 2 and 6. Yes, okay. I believe this is going to factor, and I'm going to go ahead and check that, of course. That is going to be 3x plus 2, x minus 2. Let's see if that works. 3x squared, that's negative 6x plus 2. Okay, that factors. So then, canceling those two factors of x minus 2, canceling my two factors there and evaluating at 2, my slope is 6, that is 8. My slope is 8. So that would mean, if I go back and replace m with f prime of 2, f prime of 2 equals 8. All right, now let's use the second equation just to show that these are completely interchangeable. All right, so this will be my slope, or f prime of 2, equals f of a plus h. So that is f of, let's see, a plus h. So I'm going to replace everywhere I need a limit there. Limit as h goes to 0 of 3a plus h squared minus 4a plus h plus 1 minus f of 2, which in this case we said was 2, 5, so minus 5 over h. Okay. Oh, well, our value of a is 2, so actually let's replace that with a 2. All right. Now, doing some algebra off to the side, this is going to be h goes to 0 of 3h squared plus 12h plus 12 minus 4h minus 8 plus 1 minus 5. I believe that's right. We have a minus 8 minus 4h. Okay. And then squaring that, that's going to be a 4, so we get a 12 in there. That is a 4h times 3, so 12h, and then a 3h squared. Okay. All that divided by h. If you notice, some terms cancel out. We cancel out, let's see, 12 minus 8. 12 minus 8 plus 1 minus 5. So that would be 4, 5, that is 0. Okay, all that cancels out. So we are left with a bunch of h terms. All right, so I'm going to go ahead and factor the h out. 3h plus 12 minus 4, well, that'd just be an 8. Just go ahead and do that. Plus 8. Okay, and that's divided by h. Okay, so canceling the h terms and then plugging in 0, we get 8. Therefore, f prime of 2 equals 8, as we deduced with the other formula as well. All right, next, find the derivative of this, and we're going to find f or g prime of 1. So g prime of 1, I'm going to use the second formula. So as h goes to 0 of f of a plus h, so a plus h, and in this case a is 1, so I'll replace that. So 1 plus h squared plus 3 times 1 plus h plus 2 minus, if I evaluate that at 1, that'll be 1 plus 3, so 4 minus 6 over h. All right. Using some algebra here, we get a 1 plus 2 h plus h squared plus 3, go ahead and leave that, plus 3 plus 3h plus 2 minus 6 over h. Okay, combining some terms, some things should cancel out every time. We have 3, that's 5. Okay. Okay, there we go. The 1, 3, all of our constants cancel out. 2 of our h terms combine. Okay, so we'll go ahead and factor in h out. That's going to be a 5 plus h over h. Canceling the h terms and letting h go to 0, we get 5. Therefore, g prime of 1 equals 5. All right. Now for some application. So recall that s of t is the position function for an object's motion. So the average velocity is found by using our secant line definition. That is, the average velocity is s of t minus s of a divided by t minus a for a given point A. Okay, now as we approach the point A, the values of the average velocity approach the instantaneous velocity. And now we can say the instantaneous velocity at A is the derivative of the position function, okay, which is that limit. And the instantaneous rate of change of a function at that point is its derivative at that point. Okay, so a couple of examples we have here. A lead weight on a spring is oscillating up and down. Its position at time t with respect to a fixed line, horizontal line, is s of t equals t. Determine the value of v of 0. Okay, so v of 0 is s prime of 0, which is the limit as h goes to 0 of, well, that would be a plus f of a plus h. So in this case, s of a plus h. Okay. Oh, I guess I should go ahead and use that version of it, shouldn't I? All right, so we'll go ahead and do that is the limit as t approaches 0 of s of t minus s of 0 over t minus a, so that will just be t. Well, if you evaluate sine at t and sine at 0, this is the same as the limit as t goes to 0 of sine t over t, which we happen to know is 1. So v of 0 is 1, as we discovered in the previous chapter. Next question, we have a rock dropped from a height of 64 feet. So the position is given by this function we have. So we want to find the instantaneous velocity 1 second after it's dropped. So that would be v of 1, which is s prime of 1, which is the limit as t approaches at this point 1. And if we evaluate that function at t, so negative 16t squared, actually we're going to have to evaluate that at t, yeah, we can just stick with that. Now, negative 16t squared plus 64 minus, evaluating it at 1, gets us 48 divided by t minus 1. So once we combine terms there, limit as t goes to 1. Okay, combining terms, I get negative 16t squared plus 16 over t minus 1. Now, I'm going to bring over this over the next line. If I factor out a negative 16, now leave that limit as t approaches 1. If I factor out that negative 16, I get t squared minus 1 over t minus 1. And that is going to cancel to be the limit as t approaches 1 of negative 16 t plus 1. Now, if I evaluate that, that is negative 32. Therefore, v of 1 is negative 32 feet per second. All right, almost to the end here. A homeowner sets the thermostat so the temperature in a house begins to drop from 70 degrees Fahrenheit at 9 p.m., reaches a low of 60 during the night, and rises back to 70 by 7 a.m. the next morning. So we have this function here that is the temperature at time t, where t is the number of hours past 9 p.m. So find the instantaneous rate of change of the temperature at midnight. So what we want is the instantaneous rate of change at midnight. So that is at t prime of 3. So that is a limit as t approaches 3 of t, 0.4t squared minus 4t plus 70, minus, if we evaluate that at 3, so 0.4 3 squared minus 12 plus 70 is 61.6. All right, and that is over t minus 3. All right, evaluating that 3, that is right. Okay. So that is 8.4. The next line, limit t as t approaches 3 of 0.4 t squared minus 4t plus 8.4 over t minus 3. All right, now I'm going to go ahead and use a table to evaluate this, just because I can. Let's see, minus 4x plus 8.4 divided by x minus 3. All right, so I want to get close to 3. So if I plug in 2.9, that's negative 1.64. Okay, so my value of t at 2.9, it's negative 1.64. 2.99 is negative 1.604. All right, 3.1, and I'm going to do 3.01 as well. 3.1 is negative 1.56. 3.01 is negative 1.596. So it appears, based on inspection, that the instantaneous rate of change of the temperature at that point is 1.6 degrees Fahrenheit per hour. All right, one last question. Toy company can sell X electronic gaming systems at a price of P equals negative 0.01 X plus $400 per gaming system. The cost of manufacturing that is C of X. Find the rate of change of profit. Okay, well, first off, our revenue function is the price, or the amount we make, or let me write this. The profit is the revenue, which is X times negative 0.01 X plus 400 minus our cost, in this case 100X plus $10,000. So our profit function is negative 0.01 X squared plus 300X minus $10,000. All right. So P prime of 0 is what we are interested in, or no, of 10,000 gaming systems, is P of X, negative 0.01 X squared plus 300X minus 10,000, minus, if we evaluate that at 10,000, which is going to be, let's see, how many zeros is that? All right, 1,990,000. Okay, so that limit, all right, so that would be this over, and this would be X minus 10,000, and that is a limit as X approaches 10,000. Okay, that limit approaches the value of 100. So since the rate of change is greater than 0, the rate of change in profit, so their profit is increasing, okay? Their profit is increasing, and their profit currently is greater than 0, they should increase production. So that was our question, was should they increase or decrease production? Since their profits are increasing and they're currently positive, that is good, okay? They should increase their production. All right, so that is the end of this section, probably the most tedious section of this entire course. And we'll actually look at some rules and see this as a function in the next section. So that is it, 3.1.